Hello class, today we're going to be going over lesson 3.3, and lesson 3.3 really has to do with constant rates of change. Okay, so what is the constant rate of change? So the constant rate of change is present only in linear functions. If your function is not linear, you will not be able to find a constant rate of change. So what the constant rate of change tells us, if your line is graphed, this would be the steepness of the line. So I want you guys to think for a second, where have you heard this before? If you guys are calling in your brain right here that you have heard this and you're thinking, gosh, that sounds a lot like slope, you're absolutely correct. The constant rate of change is the slope. We're going to find the slope of these functions, and we're going to do it in ways that might involve the graph and might not. So I just want to remind you real quickly of slope-intercept form. Slope-intercept form is y is equal to mx plus b, where m is the slope and b is the y-intercept. So let's take some look again at some linear versus nonlinear functions. Recall, what does a linear function mean? A linear function is a line. So all of these on the left right here are linear functions because they all represent lines. That means we can find the constant rate of change on those functions. On the right, you can see examples of nonlinear functions. Notice how they all have some sort of turn, some loop, some wave, something that makes them not a line, so they would be not linear. That means that we cannot find the constant rate of change on these. There is a rate of change, but it's not constant. And since I don't think you guys are going to learn about derivatives anytime soon, you won't have to learn about that. Just know, to find the constant rate of change, or the slope, you need a linear function. All right, so let's look at this graph here. What is the constant rate of change in the function? Remember, guys, we want to find our slope. Slope is the constant rate of change, or the rise over run. If I look at this graph here, remember, to find our rise over run, we need to choose 2 points. How about this one here and this one here? And we need to count how far up and over I need to go. Remember, it doesn't matter what 2 points you choose. You just have to choose 2 points. So I'm going up 1, 2, 3, 4 jumps, which means I need to replace my rise with 4. And I'm going over 1, 2 jumps, 4 over 2. So my slope is 4 over 2, or 4 divided by 2 is simply 2. So since my slope is 2, that means my constant rate of change is also equal to 2. My constant rate of change here is 2. So again, what we're doing on this is kind of like a review of what you've done before. We're finding our slopes. We're just calling it a new word now. Now we're calling it the constant rate of change. All right, let's look at this one right here. Compare the equation and the graph. Which had a greater constant rate of change? Okay, so first thing we need to do is find the constant rate of change from our equation right here. It's pretty easy. It's just what letter has replaced m in the equation y is equal to mx plus b. Since that negative 2 replaced my m, that means my slope of that equation is equal to negative 2. Now let's look at our slope on the other one. So we got to choose 2 points here. I see one right here, and I see another intersection right here. So I have to go down 1, 2, 3, 4 points, down 4 points. So my slope on the blue line is equal to negative 4, and I have to go over 1, 2, 3 points. So negative 4 over 3. Or this would be negative 1.13. So if it's asking us which of these had a greater constant rate of change, remember, since these are negative numbers, negative 2 is less than negative 1.13. Or that's not 1.13, excuse me, I don't know what I'm talking about. 1.3 continuing. 1.3 continuing. That since negative 2 is less than negative 1.1, negative 1.3 continuing, gosh. Or another way to say that is negative 1.3 continuing is greater than negative 2. That means the graph had a greater constant rate of change, or the slope is greater on the graph. Alrighty, let's go on to another question here. We got one more. 2 functions are shown below. Which has a greater constant rate of change? So let's start with function A here. Function A I'll do in green. Since this is a graph, we could find the slope of it by doing rise over run. So I'll start at 2, or excuse me, I'll choose my first point right here and my second point right here. So my slope is equal to rise over run. Let's If I look here, I go up 1 and over 1. So my rise over run is 1 over 1 or just 1. Now for function b, I could find slope, or I could find my constant rate of change rather, by just noticing how I increase on my going from my y values here. How am I constantly changing on my y values? Well, what do I need to add to go from 0 to 3? I need to add plus 3, right? How about going from 3 to 6? Again, it's a plus 3. And 6 to 9? Again, plus 3. So 2 things on this. 1, since we are able to identify a constant rate of change, what does that tell you about function b? Well, that tells me that function b is linear. Since there's a constant rate of change to go from all of my y values to the new y values, I need to add 3. That means my slope is 3, or my constant rate of change is 3. And since I could find a constant rate of change, that means my function is linear. So since 3 is greater than 1, that means function b, has a greater constant rate of change. Alrighty, what I need you guys to do today is write a conclusion about what you learned, 2 complete sentences. Remember, today we talked about our constant rate of change. You might want to mention, when is a constant rate of change present? Well, it's only going to be present when you have a linear function. You could also talk about how to find that constant rate of change or what you relate it to. Alrighty, everybody, hope this video was helpful for you guys. If you have any questions, please make sure to ask me them in class. Other than that, I will see you all tomorrow. Peace out, everybody.